Hello, good morning, everyone. Good morning, Jayesh. Good morning, Swapnil, Ashay.
Good morning, sir.
Good morning,
Good
Surya.
morning, sir.
Good morning,
Good
sir.
morning. Good morning, Arjun, Vaishnavi, Yashashri, Nilima.
Good morning, sir. Good morning.
Morning, sir.
Okay, so now we will start our today's lecture. Okay, so now, uh, okay, so yesterday that we have seen the algorithm, which is nothing but the termination detection algorithm. Okay, so I think you know what we mean by the termination detection algorithm. Okay, so again, I will just recap the things that we have seen in yesterday lecture. So, termination detection in a distributed system. So, what do you mean by the termination detection? So, in a distributed system, there are n number of processes are running. Okay, simultaneously in the system. So, whenever any transaction is happening or whenever in a transaction is in process, then the coordinator process, the coordinator node, the controlling agent should be able to understand that the process is terminated. So that's why the termination detection algorithm is important, or it has an significance with respect to the execution of the various processes. So when how the termination is to be detected, that we have seen yesterday. Consider again any one example, and using that example we can explain how exactly the termination detection takes place. Okay, so first of all, I would like to explain the example that I have considered in the last lecture, yesterday lecture, and then after that, from that I will ask you some questions. So I think all of you should be attentive, and I guess that everyone understood the concept of termination detection, and then I will ask you some questions on that. Okay, on the termination detection algorithm. So now I request everyone to be concentrate the whatever the things that I am telling to you about the termination detection algorithm. Just concentrate on that, how it works. Okay, and then I will ask you some questions, and that questions will be related to some examples. So what exactly you have to explain, you just tell me the example, and then how that algorithm will work for that example. You have to explain that example considering any real life example or anything which are happening around us. Okay, so just I can share my screen, and then you would be able to answer my question. Okay, so just wait. uh, okay, so yes, okay. So this is a termination detection algorithm. So just I read out the things, what is happening in the termination detection algorithm, and then after that you explain any example which are related to the termination detection. So the termination detection algorithm is being discovered or is being proposed by the Xiang Tisan Huang in 1989. In that, in this in a distributed system, the process is either the active process or the process is either the idle process. So there are the two states only. One will be active and the another will be idle. Termination occur when all the processes become idle. So when the termination will occur? When the process, all the processes in the system, when it will be idle, then you can assume that the termination of that particular transaction is over. Okay. Initially the status of the processes was active. Whenever the execution is in process, the status was active, and when it is over, the process will be idle and the termination is there. Okay, so at the end of the termination, the status of the process will be idle. Okay, so I think you got it. Now, assumptions in the algorithm. So, first of all, there is one controlling agent. One of the cooperative processes which monitor the computation is called as a computing agent, controlling agent. So I request everyone to be concentrate because you have to explain the example according to this the steps which are given. So controlling agent. So controlling agent means what? The process who monitor the execution. That process may be running on the any one of the node. Consider the banking example where the administrator has a role to monitor the every execution in that system only, okay, which is corresponding to that branch. Okay, so that will be the controlling node. You can say that the coordinator node. So the controlling agent is a node or is a process who monitor the execution of the processes in that scenario, in that environment, okay, in that application. So that is the things that you have to remember. That is called as a controlling agent. Then initially the weight of controlling agent is 1. Now what happened here? To explain the concept, here certain things are assumed. Whenever you write a program, then at that time to execute the program, to how the program to be executed, how the program to be written. Okay, so for that purpose there are the certain assumptions, there are the certain notations that you have to use. So similarly here also, to explain the example of the termination detection algorithm, here we are assuming something. So what we are assuming? The weight of the initial weight of controlling agent is equal to 1. Now all the processes are initially idle and have weight is equal to 0. Now it is assumed that for any example, first of all I will explain you one example, and after my explanation you would have to explain any example which resembles this particular scenario. Okay, so I take a simple example of banking example. Okay, so the any person who do the any transaction in the ATM system. Okay, so now I am the user. I am doing some transaction. So before doing any transaction, before happening that particular event, here I am assuming that key for that particular transaction, for that particular application, all the processes are initially idle. Okay, because the transaction is not started yet. So that's why here, for the sake of understanding, here we consider that the weight of all the idle processes are 0. Okay, here we are explaining, we are taking the flag. Now that flag value is equal to weight. Now you know that what purpose the flag is to be considered. So whenever you write a program, initially the value of flag is equal to 0. When something condition is happen, when something happen, you do the value of flag is equal to 1. Okay. Now from that particular value of flag, you understood that yes, something is, some condition is satisfied. That's why the value of flag is equal to 1. Similarly here we have to understand when the process is idle, the value of flag, that is the weight, is equal to 0. And when the process is in active state, then it must have some value which is greater than 0. I think now you understood the concept of wait. So here the weights are considered only to explain that the process is idle and the process is active. So here there are the certain assumptions and there are the certain flags are considered. That flags are nothing but the weight here in this algorithm. So under, understand this concept. Initially the weight of controlling agent is 1. All the processes are initially idle and the weight is equal to 0. The computation start when the controlling agent send the computation messages. So here there are the two types of the messages are there. One is a computation message and another is a controlling message. Now the controlling agent will send the computation message. Now in the last lecture I explained one example by showing you one video. So in that video, they have explained the things which that is to be sent from one process to the another process. So that message is called as a computational message. So what is a computation message? Any action, any action performed by the process, and that action is called as a computation message. Okay, now assuming the same example that I am explaining, which is a ATM system example. So whenever a person do the transaction of withdrawing something, okay, so what is when the process will start? First authentication. After that, after authentication, I do the further action, that is entering the amount and then PIN and whatever the things. Okay, then the action is performed. So that is called as sending the computation message. So whenever the any action is to be performed, then that is called as a computation message. So in this example, the controlling agent the controlling agent is nothing but a process who is monitoring the all the execution in that particular environment, in that particular application. So here the computing agent send the computation message to the next process. So when the computation message is sent, so along with that particular message, the weight is also sent. Why the weight is sent? Why the weight is sent? Is anyone can explain why the weight to be sent? Because initially the weight of the idle process is 0. Okay. I think you are listening to me, and it is very important concept in case of a distributed system. After my explanation, I will ask you the questions. I will ask you the example, and you have to tell me the example which are related to the termination detection algorithm. And I want that my lecture should be attentive. My lecture should be interactive, and you are listening to me, and you are able to understand the concept. Otherwise, what will happen? I'm alone that talking to you, and you are no response from the your side. So how I would like how I would know that you are understanding the concept and you are listening to me. Okay. So um, here the controlling agent is sending the message to the process. So when I am sending the message, when the controlling agent is sending the message, computation message to the process, then along with that computation message, weight is sent. Okay. So now the controlling agent as weight is equal to 1. Okay. So that weight is divided into two parts. 1 second. Okay, yes, it's working. Okay. Now when the controlling agent send the computation message, computation controlling agent has weight is equal to 1. initially, see, in the second line you can see on the screen, the initial weight of the controlling agent is 1. Now that weight 1 is divided into two parts, W1 plus W2, and W1 and W2 is greater than 0, and the addition of W1 and W2 is equal to 1. So one part of weight is sent along with the computation message to the next process. Okay, so why the weight is sent to the next process? Because initially that process was idle. That process was idle, and when the weight is sent, it becomes active. It becomes active, and the weight of that particular process will be 1. Sorry, it's not 1. It has an weight is equal to W2. Means initially it was 0, but the W1 in the controlling agent has the weight is equal to W1 plus W2. So W2 is sent to idle process along with the computation message. So that's why the weight of the idle process becomes W2. Okay, means it has some weight which is greater than 0. Now when the weight is greater than 0, it means that that idle process becomes active process, and it has to do some execution. So now again I come back to my previous example. That example was ATM system example. So whenever I do the withdraw, so withdraw is nothing but the computation message that is being sent by the controlling agent. So who is the controlling agent? Administrator. Administrator gives me the authentication that you can do the withdraw operation. So when the withdraw operation is to be performed, then at that time the weight of that idle process. So what was the idle process in that case? Nothing. Means the process who do the transaction of withdrawing. So that process has the weight is equal to 0. But when the transaction is happened, then at that time the weight of that process will be equals to W2. Okay. Now what happened after execution? After this particular operation, what happen? The weight of that particular it will send the notification that yes, I have performed the operation, and again that the result of that operation is sent back to the controlling agent. I think you are getting. So what is the operation? My operation was withdraw. So my money was withdrawn, and after the money withdrawn, so what will happen? That process will send the notification to the controlling agent. Yes, my operation is performed, and now I am returning the weight. So the whatever the weight that process okay. So that weight was W2. So controlling agent was having the weight W1 plus W2. So W2 is the weight which has been sent to the idle process. Then it becomes W2. That the idle process has the weight of W2, and then again the W2 is sent back to the controlling agent, and hence again the controlling agent has the weight is equal to W1 plus W2, which is equals to 1, and the process weight was 0. Okay, the process weight was 0 because it has nothing any weight. Whichever the weight that was received from the controlling agent, so the idle process has come, that active process returned it to again to the controlling agent. So that's why the weight of that idle process was again 0. Okay, so now here I want to tell you that whatever the example that I explained you, that is the example of the withdraw operation, okay, from the bank ATM. Okay, so in that particular case, here this particular algorithm is there. So you can see that I again read the whatever the things, all the processes initially idle having the weight is equal to 0. The computation start when the controlling agent send the computation messages to the process. The process becomes active on receiving the computation message. computation message can only can be sent only by the controlling agent or the active process. Now the control message is sent to the controlling agent by the active process when they become the idle. The algorithm assign the weight w, which is the weight of the w will be from 0 to 1, means it is greater than 1, it is positive weight. Notations to be used here, the bw is the notation, b is the computation message, c is the control message. So here the dw means the weight of that computation message. So weight of the computation message that I explained, w1 plus w2, and the part of w1 plus w2, that is the w2 sent with the computation message. Okay, now this is the algorithm that is the rule 1. Initially it was c, w is equal to w1 plus w2, w1 greater than 0, w2 is also greater than 0. Now initially when the process has to be initially it was like this. So you can see send the bw2 to the process queue. So now the process queue, initially that was an idle process. When the w2 send, it becomes active. So on receiving the w2, what will happen? W is equal to initially it was w is equal to w plus dw. Now if the when if the process queue was idle, it becomes the active on receiving the dw. Now after that, so these are the various rules. So I already explained you what exactly the process is. Okay, so don't go for the any complications which are given in the text. Okay, so the meaning is that when the idle process receive the computation message from the controlling agent, so then it becomes active and it has some weight is equal to w2. After computation, that active process again return that weight to the controlling agent. Now again the weight of that particular process will be 0. Okay, and then the weight of the controlling agent again it will be 1, because initially it was 1. It is divided into w1 plus w2, but after receiving w2 back, again it has the same weight as before. Okay, now what is the idea behind it? So I what exactly the termination algorithm in this? So here, when all the processes in that particular application has completed the execution, they becomes active. After active, again they becomes idle. So when all the processes are idle and the controlling agent having the weight is equal to w is equal to 1, then the controlling agent understand that there is a termination of that particular execution. So here there is a termination of transaction. Okay, so with corresponding to the same example, now I would like to ask you the question. Okay, uh, okay, now you can see my screen, and according to the screen, I would like to ask you the question to. Okay, okay, hello Sakshi.
Yes, sir.
Okay, can you explain me the example, any other example that I was explained related to the transaction of ATM?
Um,
Hello Akshay, Akshay Basir.
Yes, sir.
Okay, so tell me the. I will explain you the example. I will tell you the example now. consider the example of for example any shopping application. Okay, shopping means
Yes, sir.
Amazon or Flipkart. Okay, so I'm the customer who is having the mobile app application. Now I would like to explain, I would like to purchase something. So how the controlling agent in that particular application, now consider that there is one controlling agent, and the processes are going on while selecting the product, while making the uh, order, or while paying the money. Okay, so can you
Yes,
explain
sir.
me the can you explain me the termination in that shopping example, termination detection algorithm in that shopping application?
Sir, initially, when a user want to buy something, he will select. Then a coordinator will tell the particular process for that to add to cart or something and then he will process that. Uh, then he will send the after being idle, after completing his work, he will send some weight W for to the agent.
Okay,
Similarly for all the process.
okay,
Next.
okay. Very good, Akshay. At least you understand what exactly going on in the application of shopping. So now here again I explain you in case of a Flipkart application. So there may be the number of if we consider only one-to-one processes. Now whenever you start any action on Flipkart, okay, so whichever the action that you are doing, so the controlling agent send the computation message. So now to after selecting the cart, whenever I am selecting the product, it will be in the cart. Okay, so when I am then after that I am making the order, means making the order means I am purchasing that particular product. So at that time the controlling agent will send me the weight to that particular operation. Okay, and then that process will be active process. Initially it was an idle process because nothing is happening in that particular selecting the things, just means selecting the thing, definitely the process is occurring there. The process will become active whenever I do something, but whenever I do the actual transaction, then at that time the controlling agent send the computation message, and the process will be active for doing that particular transaction. After completing the transaction, again that particular process will again return the weight received from the controlling agent, and then again the process will be idle after the execution, and the controlling agent has come back with their original weight. So this is the things that could be there in case of termination algorithm. So this is related to the shopping. Similarly, you can give the example which are related to the reservation. Similarly, you can give the example which are related to the file sharing, or downloading any file from the internet, or any social media. Um, um, uh, that is the action that you are performing. For example, uploading a photograph. Okay, nowadays you know that whichever the things that you have to do, you need a permission. Okay, and if it is related to means which type of the photo that you are uploading, or audio that you are uploading, so to do that transaction you need some authentication. So first of all, authenticating the user is also one of the computation message, means you will become active. And then after that, whichever the transaction, whichever the operation that you will be performing, that all the operations is according to the authentication that you have received from the controlling agent. So you are carrying the weight. Okay, you were carrying the weight that is being came from the controlling agent. So here it, in this particular application, whichever the application is there, so here it is assumed that the controlling agent is sending some weight along with the computation message to you. Means to you means for the active process which is in the execution. So after execution of, After execution of messages, after execution of this particular action, then that process will again send the weight back to the controlling agent after the completion of that particular event. Okay, so I think you are getting my point. What do you mean by the termination algorithm? So termination algorithm is an algorithm who detect the termination of that particular process in a in a in a system. So there are so many cooperative processes which are in execution in the distributed application, and in that particular case, uh, the controlling agent or the administrator or the any active process in the node want to know the status of the execution. So whenever the any process want to know the status of the execution, that process are sending the controlling messages. Any active process can be the controlling agent. Here here you have to understand it. Okay, I am saying the controlling agent. Why I am saying the controlling agent? Because at least one node or the one process in the system can be the active process. Now everyone knows that the concept of the coordinator node, the concept of the active node, the concept of the administrator. Okay, so in a distributed system, in a client server model, the server will be the acting as an administrator. In the peer-to-peer system, any node can be the coordinator or the administrator. So at least one node in the system is a monitoring node who will take care of the execution. So I think all of you know that whenever some operations is being performed, you have to monitor that particular operation for any particular system. So that's why I am saying that controlling agent. Otherwise, any node in the system can be a controlling agent and can monitor the status of the other processes. So that's why in a distributed system, okay, in a distributed system, one has to know that the status of all the processes which are running inside the system means the state of the global state of the system. So now you know that the state of the system that is recording the event. Okay, so that is all about the termination algorithm. Now today that we will discuss the another algorithm, again the same, which is a deadlock detection algorithm. Now first of all I would like to ask you, what is a deadlock? Okay, so yes, uh, the question goes to Ashish. Hello Ashish. Ashish Wagmare.
Yes, sir.
What is deadlock?
Ideal processor.
Yes, I'm not getting.
When process is completed, then deadlock occurs, sir.
When process will complete, deadlock is occur. I'm asking about the deadlock in, you know, the deadlock in the operating system. Yeah, I think everybody knows the deadlock. Okay, actually your answer was wrong actually. Uh, Hello Swapnil Khandagade. Do you know what is a deadlock? Hello Swapnil. Okay, Swapnil is not present actually. Okay. Then hello Ayush Agrawal. Ayush. Hello Ayush. Hello, Nilima Shinde.
The deadlock is when process or thread occur in a waiting state.
Okay. Hello, Prajakta Varke. Hello, Prajakta. Okay. Hello, Prajwal Shete. Hello, Prajwal. I was asking you the simple questions which are related to the deadlock. Everyone, I think everyone knows it, what exactly the deadlock is. Then why people is not responding? Hello, Rutuja Tambe.
Hello.
Hello.
Sir, am I audible?
Yes.
Hello.
Yes, audible, Rutuja.
Yes, sir. Actually, when two or three processes are taking place and one process has the resource and other two also require the same resource, so they wait for that. So at that time, deadlock occurs.
Okay, very good. Thank you, Rutuja.
Thank you, sir.
Okay. See, this was a simple questions, and I think all of you know it actually, but you people are not responding, not taking the part of the discussion. So I am very disappointing in this particular case. I think you must have to answer the question, whichever the things that you know, you have to tell me. Okay, so deadlock, everyone knows that in any application there are the so many processes are running on. Okay, and there is a shared resource. There are some resources which are sharing with everyone. Okay, now when the deadlock will occur, there is a limited number of the resources. Every process is attached with some resources. Now what happen in at particular moment, the sum of the processes are stuck in that particular circle in a such a way that no processes will get, means in that particular region for that particular resource, we can now assume that no processes are getting the resources that they have, that they want, and they stuck up in that particular circle. Then in that particular case, there is a condition of the starvation is there, and they are not able to get that particular resources. Everyone is waiting for everyone. Okay, so that condition is called as a deadlock condition. So it is very simple for you also to understand the concept. When there is a waiting state, means infinite wait, not only wait, Nilima and the Rutuja, when there is an infinite wait, not only a wait, when there is an infinite wait, that the process becomes a loop. Okay, it is in the loop to get that particular resource which is held by some another process. So when they are in a loop and they are not able to get it, then that condition is called as a deadlock. So I think all of you know it and you are not able to answer me. So I am very much disappointed with your approach. Okay, so now what do you mean by the deadlock then in the distributed application? So what is the deadlock detection in a distributed system? Same thing happen in a distributed system. Here, what do you mean by the detection? Now there are the other terminology in case of a deadlock detection, then deadlock avoidance, deadlock protection. Okay, so now here we are talking about the deadlock detection. So detection means to identify that whether there is a deadlock in a system or not. Okay, so how the processes will get to know that the system is in the deadlock state? In a distributed system, so many nodes are involved. Okay, there are more than one nodes are there in a distributed system, and there more than means there are many more processes are concurrently executing in the distributed system. There are many more resources are there, which are the common resources. Common means shared resources in a distributed application. There are many common interfaces in a distributed application. So when it is a very large system, then at that time, how you will get to know that deadlock is occur somewhere? Because at some point of time, the other part of the process is also running very smoothly. Because distributed application, whenever the deadlock is occurred at somewhere in the system, it is not likely that the overall system will be get failed. No. In case of a distributed system, some part is executing in a very smooth way, but some part of the system may be in a deadlock. Are you getting me? This is the case when there are several resources, when there is a replication of the data at any node. So according to the various property of distributed system, that is the replication of the data is there, replication of the servers are there, replication of the nodes are there. Okay, when such type of systems are exist, then the deadlock will not occur in a whole system. The deadlock may occur partially. Okay, but when the deadlock is occur partially, then how the other processes will get to know that the deadlock will occur in that particular region or in that particular zone? Other systems are working fine. So here there is a approach which will find out that how to find out the deadlock. So this is a deadlock detection algorithm. So as a you can just read out it in a distributed system, deadlock can neither be prevented or nor avoided as a system. It is so vast that it is impossible to do so. Therefore, only the deadlock detection can be implemented. Okay, we cannot avoid. So here, as it is a vast system, so it neither be it is prevented nor it is avoided. At some point of time, it may be there. Okay, so here only you have to find out the deadlock detection. The technique of deadlock detection in the distributed system require the following. First is a progress. The method should be able to detect all the deadlock in the system. Safety. The method should not detect false or phantom deadlock. So what do you mean by the false and phantom deadlock? So here actually it is nothing but you can say that false or phantom means what? It is just a for a few seconds, or it may be if just a we can say um, that is there, but it is not actually. Okay, the process may be in the loop. You may have an you may have an we can say that you may have a feel that all the processes may be in a deadlock state, but it could not be, but it is not actually. So that particular state, we can say that the phantom deadlock, or we can say that it is a false deadlock. Okay, so there are the three approaches to detect the deadlock in distributed system. First is a centralized approach. In the centralized approach, there is only one responsible resource to detect the deadlock. Now, as the name already gives you the idea that what exactly the centralized approach is. In a centralized approach, it is assumed that there is only one node who is able to detect the deadlock in all, overall the distributed system in for every node. The advantages of this approach is that it is simple and easy to implement, while the drawback include the excessive workload at the single node, single point of failure, and it is a single point of failure. When any means when that particular responsible node fail, then you cannot find out the deadlock. So that is a centralized approach. Only one node is responsible to find out or to detect the deadlock is there in a system or not. So this is called as a centralized approach. So what is a distributed approach? In the distributed approach, different node work together to detect the deadlock. So it means that the daemon process is running on every node in a distributed fashion. It is in a such a way that they will identify that whether the deadlock is in the system or not. So that is called a distributed approach. Consider the example that here I am in the region. For example, I am in the region of Shivajinagar. Okay, and some nodes are in the region of Katraj or somewhere in the Swargate side, or some nodes may be in the region of Hadapsar or in a Sinhagad road or in a Senapati Bapat road, University side, Baner, Balewadi, and everywhere. Okay, so here what exactly that in a distributed fashion, that particular daemon process, the daemon process means what? Here I would like to identify the some node in that particular region that will be they are responsible to identify the deadlock. So whichever the process or that is to be required to identify to detect the deadlock, that will be running in that particular region, and they will detect the deadlock. Okay, so that approach is called as distributed approach. Then there is one again approach that is called as a hierarchical approach. So this approach is the most advantageous in the combination of both centralized and distributed approach of the deadlock detection in a distributed system. So this is the most important and most advantageous. Why? Because it is combination of centralized approach and the distributed approach. So how it is the combination of the centralized and distributed? So in this approach, some selected nodes or cluster of the nodes are responsible for the deadlock detection. Selection of the node or the cluster of the node. Now here I assume that in a as you know that there is in a centralized algorithm there is only one node who is responsible for the detection. In a distributed approach, the region wise the nodes are responsible for the distribution for the detection of the deadlock. But in this approach, hierarchical approach, here I would like to create the cluster of the node. For example, some of the five nodes or some nodes, 2 3 nodes from my region, 2 3 nodes from the another region, region number 2, region number 4, region number 5, and then I would like to communicate all these region by one central node, and then that central node is responsible to get the notification from the different regions, different clusters, so that clusters are connected to the central node. So that particular approach is called as hierarchical approach. Okay, so this is the more advantageous approach. So this is all about the deadlock detection algorithm. So actually the algorithm, I will explain the algorithm in the next session. How that algorithm, how to identify or how to detect the deadlock. So now you know the basic approach of the deadlock detection. Okay, so there is a wait for condition is there. So now everyone knows that the wait for graph. So wait for graph means what? There are certain processes are shown, there are certain resources are shown. So the process is demanding that particular resource. That resource is held by some another node. Then that process is again held by some next resource. So here there is a the circular wait condition is there. So that is called as a wait for graph. So every process in the system is waiting for some resource in that particular region. Okay, and then the wait for condition is happened. So that wait for condition or the wait for graph, you know the wait for graph. I think you have an idea of the wait for graph. Everyone I think knows it. It is a wait for graph. So if I would like to tell you what exactly the wait for graph is, so you can see the images in the wait for graph also. So this is the case where there is a wait for graph. So you can see the diagram here. The the processes are there, and that processes are holding by someone, and then there is a circular wait conditions are happening. So that is called as a wait for graph. So you can draw the wait for graph accordingly. So this is the case where there is a the deadlock can happen. So all these are the examples that will tell you that how exactly the wait for graph is. Okay. So now we will move ahead to the next point. That is our term. That is our the wave algorithm. Okay. So this algorithm that we will take later on deadlock detection, because it is a it has a certain steps, and then I will explain you what exactly it is. Now the next part that is there in your syllabus, which is a wait for, that is a wave algorithm. So what is a wave algorithm? Okay. So now I you can see my screen. In a distributed computing, the process often need to gather the information from all other processes in the network. Okay. Now, what is the need for this? Can you explain me? In a distributed computing, the process often need to gather the information from all other processes in the network. So what is the need? Why there is a need to gather the information from all other processes? Because every processes has an the same equal and the same weight. They have an equal opportunity, they have an equal access to the different resources. That's why they need to know that what is the status of the processes. And in a distributed snapshot, you know already to record the state of that particular process. So how to record the how what do you mean by the global state of the distributed system? Global state is to record the local state of the processes. And what is the local state of the processes? Local state of the processes means what is the current execution state of that particular process. That may be the running state, that may be the idle state, or that may be holding some resources at that particular moment, or it may be the wait state, or a deadlock state may be there. So the local state of the process, it means that whether they may have in execution, they may be not in the execution, or the in a global state communication channel, the state of the communication channel is also required. Okay, so in a global state, the state of the channel is also important. So here in a distributed application, a process often need to gather the information from all other processes in the network, but for that particular process, the wave algorithm is required. So what is a wave algorithm? In such cases, the process initiate the wave algorithm in which each computation is called as a wave that satisfy the following. So what are the conditions that they have to satisfy? First, it should be a finite process. it contains one or more decide events, and for each decide events E and process P, F tends to E, means F includes V, E for some events, or you can see that the F proportionate to E for some event F at P. So what does it mean? It means that the first condition that it is a finite. Okay, finite means it should have some termination. It should not be infinite. So that is the termination detection algorithm. Means that particular process should be finite. Whenever it start, it should have to end somewhere. So that is the first condition to be satisfied. Then the second condition is that it contains one or more decide events. So what do you mean by the decide events? Decide events means what? There are the certain things that is to be operated or that is to be executed with some conditions, with certain decisions. Means for example, if I am executing this, then after this this will happen. If I am giving some input a is equal to b, then by giving that particular input the event will be occur. Means there should be certain things which is to be required to for the happening of that particular event. So that is called as decide event. So it contains one or more decide events. It should not, means if the null, means if there is a nothing is the decidable factors, then it could not be. The wave algorithm will cannot identify the state of that particular process. To identify the state of that process, there should be one or more than one decidable events. So when and for each decide event, so then the next condition is depends upon the first condition. So what is the next condition? For each decide event E and process P, so F proportionate to E for some event F at P. So event F. So F is the one of the condition. F is the one of the state, and that state is in that particular F. Is in that particular P. That is that way. That condition, that state is the part of that particular process, and that particular state should be proportionate to that particular event. So the F should be proportionate to that event E. Now consider the example of the same ATM system. In that particular case, there are the certain, okay, so I think our time is up. There are the certain things which are to be happening in that case. So when one event is depending on some other event, when one event is depending on some other event, then at that time we can say that F is the one of the state in that particular event which is the proportionate event in that particular P. So okay, we will continue this in the next lecture. Just wait for a attendance.